Hi guys, this is another tutorial. In this tutorial, I'll use the previously developed project with the optimization of the AI enemy, and I will write some code here in order to show you how we can use the exact same logic we used for the optimization of the AI in order to optimize a weapon that will be attached uh, to our player. So for this reason, I will create a new script. So right click here, create C# script that I will name it as weapon optimization. And I'll use this script in order to assign a weapon to the player, and also in order to optimize some characteristics of the weapon. In my case, I will try to optimize three parameters of the weapon, which would be the frequency of the generated bullets, the size of each bullet, and the speed of the bullet. So again, we will be using just a single value to control the weapon, the functionality of our weapon, but this value could also correspond to the damage, for example, you might cause to an enemy when you interact with the enemy. So a small value means that you affect a small value affects less the enemy, but a high value might affect more the enemy. So I have created this script. I will double click it just to open it here, and I will attach it to my player because the weapon is part of the player. So I'll drag and drop it here, and let's go to the Visual Studio to see how this optimization of the weapon looks like. So the first thing we need is the spawn point that the bullet should be generated. For this reason, I will create an empty object as a spawn point, and I would like to put it as close as possible to our player. So here it's our player, here's the spawn point. I think that bullet should be generated somewhere here. So it's invisible object, but it can be a visible object. Okay, and the next thing is that I want to put it as a child of our player, and I'm gonna rename it and name it as spawn point. Okay, next thing I will go to my script here, and I will start by defining some variables. First of all, we need to have access to a bullet. I will create this bullet right after writing a couple of lines of code. So, and I would also define the spawn point. So I will define a variable rigid body, and I will name it bullet, and another variable which is just a simple transform, which I will name it spawn point. Okay, as I said, I need a bullet, so my bullet could be a single sphere. So I will create here a sphere, and for my bullet, okay, go here, back, I have some materials. Where's my sphere? Okay, I'll move it here and change its size. I think, okay, let's say this is a decent size for my bullet, and my bullet should be green color. Okay, so let me rename it as bullet, and I will drag and drop it right now here, and I'll create a prefab of bullet, so I don't need here anymore. And I'll go back to the player that I have the script attached, and as you can see here, there are two different positions. I can attach different objects. So I will attach the bullet. I will drag and drop it. Come on. asset. Okay, it's a rigid body, so there's a problem here. I will move it back here and I will attach a rigid body, or I can do this here as well. I think add component rigid body, so I don't need here anymore again. Okay, here's my player. Suppose now if I choose assets, nope. Okay, it allows me to touch here, and then also plan to touch this spawn point that I have inside my as a child of my player to my script. And this is it for now. Let's go back to our script to write a few lines of code in order to see whether it works or no. Let me first here in the update function use some input in order to see whether it's working or not. So I'm gonna say that if input input dot get button down fire one. So this is just the left click. If you click with your mouse, then the system should instantiate the game object and start shooting. So I will be using this rigid body. I will call it this variable instantiate projectile instantiated projectile, and this one should be equal to an instantiate, and I have to put some parameters here in the inside the parentheses. So the first parameter is the name of the object that we need to instantiate. In my case is the bullet. Then we need to define the position that the object should be instantiated. In my case it's going to be the spawn point, and because it's a transform we need to write also dot position. Okay, and the third thing we need to mention is the orientation. We just type transform dot rotation. Okay, transform dot rotation, and because we need to instantiate as a rigid body, we need to write out after the parenthesis that this should be instantiated as a rigid body. Next thing, we need to instantiate to assign to our bullet is some additional parameters. In my case, I need to instantiate now the velocity. So I will use this name instantiate projectile dot velocity. So we are accessing now the velocity of the rigid object, and I will type here transform dot transform direction, which says that assign this velocity to this particular direction, and then I will use a vector3 value to assign some velocity to our rigid object, our bullet. So for this I'm gonna use this new vector3 value, which will be 0 0, and the direction is this is the forward direction for our bullet. So I will use a value which is called bullet speed. So this value has not been defined yet, so I will go up here at the top and define a couple of variables I need. The first variable, all of these variables are going to be private. So the first one is a private float bullet speed. So for now I can assign a value equal to 10. This will change later. There I need another private which is float, which is gonna be the bullet frequency. bullet frequency, private float bullet frequency. I will use a value of 10 and or less than 10 actually, a value of 0.2 might be much better. Okay, and the third value that I need is the bullet size, and I will assign a value equal to, again, 1.5, let's say, a small value. These are values, all these three values are values that we will optimize later, but I just assign them here in order to show you how things look like. The next thing that I need here is that because we'll be generating different bullets, we need to define the some parameters of the bullets. So the first parameter is the velocity, the speed of the bullet, and the second parameter would be the size of the bullet. So in this case, I will be using again this instantiated projectile, and I will use the transform dot local scale. So this acts as the local scale, the local size of the bullet, and assigns a different size to the bullet. And again, because the size can change in X, Y, and Z position, we'll be using a vector3 value. So again, new vector3 value, which is equal to our bullet size. We need the uniform resize of the bullet, so I'll be using this value size X, Y, and Z for X, Y, and Z. So I save it and hope that it will work. Let me check. So there's no error. It looks like there's no error here. Suppose that if I just click the button, okay, you see we generate some every time I click the fire button, the click on my mouse, it generates bullets. We can change parameters, as I said, like the size of the bullet and the speed. So okay, let me go back to the code. Here I can change the speed to, I don't know, 50, let's say. Might be low, let's say 25 or 30, and we can change the size to 0.2 here. Come back here. Let's see how the bullet look like. It moves faster and is smaller in size. Okay, and these are parameters that we'll optimize a bit later. Now back to my code. The third parameter we need to be able to control is the frequency. Currently I'm not using the frequency, so I just wrote this code in order to figure out whether it's going to work or not. So let's also develop the frequency parameter, or assign the frequency parameter to our system. So for this reason, I will create a new method which is gonna be called void launch bullet, and in this method I will copy and paste, or basically I will cut all these values and paste them here, all these three lines, and this is what I need for now. And we'll use this if and also an else, which is gonna be if the button is up. So what we're gonna do, we'll write code that says that as far as the key is pressed, the mouse button is pressed, start shooting, and the shooting should stop once the mouse button is released by the user. So we'll be using a method, this is a Unity method, you can search online for it, which is called invoke repeating, which means that repeat this action as far as the button is pressed, and repeat this action that much often. So you can search online for this, it's called invoke repeating,
So this is a unity function, it's not my function. And with this invoke repeating, first of all we need to call the method. So we in our case we will be calling the launch bullet. This is our method that we'll be calling, and this is a special case of methods in order to that is used to call a method. And to call this launch bullet, we actually call it as a string. So we add these quotes here and paste the name of the method. Let me change it to launch bullets. Yep. The next parameter that we need to define is the time step that this repeating thing should start happening. So we can use here, generally we could use 0, which is the 0 times, which is the once you click the mouse button, but I think that it's not advisable. So I would say using a small value like 0.1. I'm going to put an F here just to let it know that it is a float value. Means that it's gonna start, right after you click the button. It's let's say yeah, it's well, less, it's just a one frame. So after you click the button, it takes one frame to start generating bullets. And then the next parameter we need to define is the bullet frequency, and this is the parameter that we will optimize later. And then we can here in the else we also need to define what is going to happen if we release the button. So as far as the button is pressed, then the system is going to start generating bullets based on the bullet frequency we define. And then when we release the button, we need to stop generating bullets. So we'll be using a method which is called cancel invoke. And this cancel invoke just needs one parameter, which is the name of the method we need to cancel. So I think that, okay, we have also defined the bullet size, the bullet frequency. Suppose that this will work for now. Let me see how it looks like. Okay, they say that we have an error here. If, okay, what is the problem? Invoke repeating. No. Okay. Frequency. Interesting. Okay, it's else if, my fault. Okay, we have the code we need, no error. So let's see how it's gonna work. I click the button and you see we have a very small frequency number. So there are a lot of bullets generating one after other. Okay, I will stop it and I'm going back here to change the frequency. I will change the frequency to an even smaller number like 0.05 to see what's going to happen. Suppose that this isn't going to generate really yep, this is what is happening. And let's change this to 0.5. So this is the frequency now. So these are parameters we will control with our optimization. We will control the frequency, the speed of the bullet, the frequency of the bullet, and the size of the bullet, as we did before. So for now on, this update and launch bullets part won't change. What we need is just to optimize the values of the frequency, of the speed, frequency, and size. So we'll be working here in the start method and we'll optimize it before the game starts. So we also need the number of other values. As we did before, we need some random, some variables to hold the random values we generate, and we also need the target, the current, and the proposed values for the optimization. So I will create these random values first. So I will use again a private float for rand. Let's bullet speed. I'm gonna use this speed. Oops, and we'll paste it. We need a random for bullet frequency and a random from bullet size. Okay, and these are values that we will generate here. There are no optimal values for random speed, frequency, and size. Depends your game. So I will be using some ranges. I think are reasonable, but you might need to change the ranges. The other thing here is that, as you can see, we have a value like 30 and the value like 0.0 and 0.5. So it's definitely difficult to control the whole game with a single value. So we'll be also normalizing the values in order to more easily interpret what is happening or how powerful is your weapon. So in my case, I think that for the speed, a random dot range, which is between, let's say, 10 and 30, might be reasonable, but you might need to change this value. So the 10 is the slowest and 30 is the fastest the bullet could go. So this is the speed I will create here. For frequency, I think for frequency a value like 0.5 maybe, or 0.1, let's say, and 1 might be a good option. Again, you can play with the values, with the min and max values for each range. Your game might be a bit different compared to my game, and I will use again this 1 and 0.1 and 1 for the size. The other thing I need to define is the target, the current, and the proposed power of our weapon. So I'll use these three values. I will create a public for the target weapon power, which is the value that you control that controls the power of your weapon, and you will be able to control it. So I will create this public float target weapon power, and you can define it as a value, let's say 2. We'll test different values later. So we have the target. We also need, as I said, power. I will delete this, I don't need this, and I'll make them private and private, and instead of target we need the current and the proposed, and these are the values we need for our optimization. Okay, now since we have all values we need, or we have all variables we need for our optimization, we'll start working on optimization. First of all, we need to define how many times will we need to iterate in order to find the optimal solution. I will create a loop, so I will create again as before a loop that runs for 100 times. So I equal to 0, I less than 100, and I plus plus. You can use different kind loops. I think that for loop is reasonable to be used for this particular application. Next thing is that I need to generate these numbers inside my loop. Okay, and the next thing I need is to normalize my values. As I said, we have different ranges here, and it's much, oops, there's a problem here. As I said, we have different ranges here, so it's much difficult to represent with a single value how powerful is our weapon. So ideally, I would like to normalize them and make them all three values to be between 0 and 1. So the maximum we can get for each one is 1, but the maximum as a weapon is 3, because we'll sum them up later. So which means that if we give a value of 3, this means that we have a very powerful weapon, but if we give a value like 1 or 0.5, means that we have less powerful weapon. If it doesn't make sense, let me know. I will explain it more. By the way, feel free to ask me questions on Discord in case there are parts of this process that you cannot understand. So in order to normalize the values, I will create this float. I will call it random bullet. I will use this run bullet speed normalized, and will be equal to actually you can search online to find how to normalize value, the equation, or I can just add a comment here for the normalization equation, which is that the normalized value is equal to the input value minus the mean value of the range over the difference between the max range minus mean range. Okay, so which means that, for example, for this normalized normalized bullet speed value, random normalized bullet speed value, is equal to this random value that will generate from here, from this line. So parentheses minus the mean rate. So our mean is 10 from here over max, which is 30. Oops. 30 minus 10. And this is the way that we normalize. So this means that whatever is the input value, it's going to be something between 0 and 1. It's normalized. If it's 15, it's going to be something like 0.2. If it's or 0.3. If it's 20, it's going to be 0.5, and so on. So I did this for the random bullet speed. I have to do the exact same thing for the bullet frequency and the random bullet size. So float bullet frequency equal, I will copy this and use this random normalized here, and the mean is 0.1, and the max is 1 and 0.1. And I'll do the exact same. I'll copy and paste it here for the bullet size. So this goes bullet size normalized. This is how we'll be calling it. So in this, okay, so we're done with the normalization. Whatever value we generate is going to be between 0 and 1. And because, as I said in my previous tutorials, that we need to control the difficulty of the game level, or the how powerful our weapon is based on a single value. Now, since all three variables in the same range, we can sum them up. So in this case, we know that if we sum them, if we get 3, so let me sum them up first. So this is the proposed weapon power. So the proposed weapon power is equal to normalized plus the normalized plus the other normalized. Okay, so we're going to have a very powerful weapon if we assign a value equal to 3, and we will have a less powerful weapon if we assign, let's say, a value equal to 1 or 0.5. So we have this value here. We can compute it. The next thing is to accept or reject the optimized solution that our optimizer is going to be giving, or our searching process is going to be giving. So as before, we'll have to create this if statement here that will compute how far from the target value it's the proposed value, and we'll accept proposed values that makes the subtraction between the current and the proposed, or the target and the proposed, close to 0. So again, as I did before, I will use the mathf.abs in order to compute absolute values. So it's one subtraction here compared to another one. So what I said before is we need to make our proposed become closer to target. So this is our target, the 2 minus the proposed, which is computed here, and we need to compare this one with the current. And here we say that if this is true, if this is smaller than this, if the proposed solution gives a smaller value than the current solution or current weapon, optimized weapon, then we accept it and make our current weapon, our proposed weapon, our current weapon. So our current weapon will become proposed, and since we accept here the value, means that these are the optimal values we need to assign to our weapon. So we need also to say that the bullet speed should be equal the random bullet speed, which is the one lastly generated. The bullet, not here, frequency should become this one, the random bullet frequency, and the bullet size should become the random bullet size. Another thing here, before we continue, because these values might mess up a bit your optimization, I would suggest you to delete all of this from here and let the optimizer find what are the values we need. After this, this is almost done. One thing, just for our validation purposes, I think that it's worth printing the values in order to be able to understand what is happening. So here I will print, and for sure for debugging purposes, I will print this in order to figure out if it becomes 0. If it becomes 0, means that we are able to achieve our goals. And I will also print the speed, which is, it's gonna be this random bullet speed, and I will print also the frequency, which is gonna be this random bullet frequency. Come on. Okay, I will print the normalized values actually, because this makes more sense. Notice that although I'm creating these normalized values, here I'm assigning the actual values, not the normalized values. Okay, the normalized, for sure, there is a mapping between the normalized and the actual values. But if we assign the normalized values to our weapon, there is a high chance that the normalized values won't work for our weapon. So we need to assign the actual values. And as far as the process was linearly. The actual values that I'm assigning is the normalized correspondence of that value. So it is the right value that we have to use in any case. So we have the speed, we have the frequency, and the next thing we need to print here is the, what is the third variable? It's the size. Size, oops, which is gonna be this round bullet size. Oops. Okay. I think we're done. We can just go back to our code. Let it compile. Suppose there is no problem. Okay, let's click play and see how it behaves. First of all, I'm gonna stop it and let's see what we have here. Here we have this value, which is the optimized value. It's 0.05, 07.03, 029, 025, 11, 008. So as you can see, the score decreases and goes closer to zero. As I said, the goal is that we go closer to zero, and as far as we go very close to zero, the optimized solution is considered as acceptable. So we're able to reach an optimal solution. So the score we assign here, it's the target weapon power, it's equal to 2. And if we sum these three values, the speed 0.42 and the frequency 0.67 and the size 0.88, it's going to give us something that is very close to 2. I can just make this 1 clear and play again to see the difference. Okay, so we run more iterations here. We start by 0.9, 0.4, 0.13, 0.11, 0.05, 0.27, 0.24, 0.14. So as you can see, as the iterations evolve, we were able to achieve better results all the time. Here you can see that the speed has a value of 0.5, the frequency has a value of 0.23, and the size has a value of 0.24. Different values. I can run it one more time. You can see that the optimal solution has different values. Okay, the optimal solution here has it reaches also it's very close to zero. So the speed is 0.13, the frequency is 0.59, and the size is 0.24. And we can actually hit. So I'm just continuously pressing the mouse button, and this is how the bullet look like. I can stop and play it again. There won't be much difference. There might be some difference, but not a lot of differences. So higher frequency, smaller size here. Let's try it one more time. Let's see what we can get. Okay. Higher value for frequency, low value for speed and size. I'd like to see a greater size value. Okay, yeah, this is what I was expecting to see. So you can see bigger in size balls, but the frequency is low. It's 0.17. The speed is also low. That's why they don't move fast. So we can use this value of the target weapon value, weapon power, and say that because the score is low, or because the weapon that I have procedurally generated suits in this way, we cannot assign a lot of damage to our enemies, but we can have more powerful weapons. For example, the highest value we can get is 3. Okay, or let me first go to the value close to 2 and see how it looks like. So this is gonna have affect or gonna have some medium damage to our enemy. So I'm gonna just press the button here. Okay, they move faster, but the frequency value is higher. So the balls do not move fast. I can run it again and see what is gonna be the difference.
Okay, bigger in size, the frequency is about the same, and the speed is about the same. So let's say change this one to 3 and see how it looks like. So frequency, high value, size, high value, speed, high value. You might need to experiment with the target weapon power in order to figure out what is the best weapon powers, or what are the best variables to assign to your weapons. For example, here, let me go back to the code. I think that one problem that I figure out is the frequency. I think that changing the frequency to point 0.1 to point 0.5, okay, 0.5, uh, 0.01 to 0.5 might be a better solution. So here I will change this to 0.1, and this one is going to become oops, 5, and here 0.01. Okay, now let's see how the weapon is going to behave. So again, you need to search a bit to find what are the better values for your approach. But it's a good solution, especially if you are creating a multiplayer game with some enemies, AIs, and also some AI, also some functionalities to control the your weapon. I think it's a good approach to use this method. So each player, for example, or each enemy might have a different weapon with different functionalities that has been procedurally generated. I will use again a value of 2 and show you how it looks like, or a value of 1. Let's say less powerful weapon again. Yeah, the speed is low. You might need, again, as I said, to find out what are the optimal values or the optimal ranges for speed, frequency, and size. Besides this, we followed the exact same process here to optimize the weapon, the power of our weapon. We just try to figure out whether the proposed weapon power is close to the target. The target is a user defined, or it can be randomly generated. For example, here in the start, you might need to define a range, and this weapon power could be generated randomly. How to do this? It's simple. Let's say that here you define a range between I don't know, or 1, let's say 1, 2, let's say 3. I mean, right now it takes values between 1 and 3 because of this variable we compute. We cannot assign higher values. Actually, we can, but it won't give us other values. It actually can give us values between 0 and 3 in this case, but I think that 1 to 3 it's a reasonable, or 0 to 3, let's say, and we have this value here. Okay, I think that it will work. So it will automatically compute a new target value here. Let me see. Okay, the generated value is 0.4. This is how our weapon look like. I will stop and play again, and the new value is 1. Oops. So you can see we can get that a number of different weapons here right now with this approach. Or actually, what I can do to make our life much easier, oops, I will create a few instances by okay, okay, I will delete these cameras, we don't need them. So I create a few instances of objects. Let's say we have a multiplayer game with multiple players with different weapons. So suppose its player right now is going to generate its own weapon. Yep, each player has its own weapon, or the same weapon with different functionalities. Look at it. I think that this is really nice. It's a really nice functionality to put in your game, and also to consider it for other projects. So, and here I just optimized one value, or three values, sorry, three values. You can add more parameters. You can look at other parameters that the weapons have in order to create weapons with different kind of damages that they can cause to the enemies. Okay, this is it. I will stop now. In case you have questions, as I said, feel free to text me on Discord or send me an email. I prefer to use Discord for communication. And if you want to talk more about this project, or if you have ideas and you want to implement this kind of weapon functionality to your project, and you might need to add some additional parameters, let me know. I can help you with this. Moreover, in case you need similar tutorials on how to optimize particular parts of the game, let me also know. I'll be able to create a few more tutorials, and we are planning to upload a few more tutorials in the next few days. And these tutorials are tutorials that you have requested so far. So yeah, feel free to ask me for other tutorials. I'll be more than happy to create them and upload them on Blackboard. Okay, have fun and stay safe.